Hello, students. This is a question which is interesting. I found the question says that a small particle of mass m0 is present at origin of a rough horizontal surface plane having coefficient of friction mu. At t equal to 0, a constant force F bar is equal to F naught I cap, which is along horizontal, and simultaneously a velocity of V naught J cap is imparted to the particle. It has been observed that finally, after sufficient large time t0, particle starts moving parallel to the x-axis. So we're supposed to find the velocity of the particle as a function of time t greater than t0. So let me explain the situation here. So this is the plane surface. We can consider this as x-axis and this as y-axis. So this is the path in which the particle travels, the white line. So it starts here at origin, as it is given a vertical component velocity v0 along y-axis, and simultaneously a force f0 is also acting on the particle. So now it was told that the particle will move parallel to x-axis after large amount of time. The reason why it moves parallel to x-axis is because of the friction. So here we know that friction always acts in a direction opposite to the direction of the motion. So let's say at a particular point P, the velocity is in this direction, which is tangential to this path V. Then obviously friction would be also tangential, but in the opposite direction. This is the direction of the frictional force. This question I found it in Nitin Sachin sir's channel, which is Indian School of Physics, and that's a wonderful channel. But I found I think I can I solved it in some few steps less compared to him, but that was anyways wonderful explanation from him. So let's continue. This is V and this is F, which is frictional force, and the horizontal force is here, which is F0. And let's say it makes a parameter angle phi, which is variable, and it varies from 90 degrees to 0 degrees as it goes from origin to this point. So now let's solve this in taking two equations. One is, since this is frictional force, it can have two components here, which is this component. If this angle is phi, this is also phi, then it becomes F cos phi. Let me use the different color here. Yeah. So the net force along horizontal is, I can write this way, F0 minus F cos phi. This is the force along horizontal, so I can write this as m into velocity along horizontal is dvx by dt, which is what we're supposed to find. I mean, after a long time, it will have only horizontal velocity, dvx by dt. And also it is given that to use f0 as mu mg. So I can use this as mu mg. Also frictional force, we know it is mu mg. Since f0 and f are same, I can write this as mu mg into 1 minus cosine theta, cosine phi, which is equal to m into dvx upon dt. So this is one expression I've got in horizontal direction. Now I would like to make the component of this force f0 which along this tangential direction, which is the net velocity, which is along the tangent, then it would be f naught cos phi. Now we can also write the expression along the tangential of this path, which will give you f naught cos phi minus this is the frictional force F, because it is opposite direction and tangential, minus F is equal to m into, since that is a net velocity, we can write this as dv by dt. And also we know that f0 and mu mg are same, so I can write this as mu mg into cos phi minus 1 is equal to m into dv by dt. So the difference in these two expressions is, first one is the equation for velocity along only x, and the second one is the velocity, which is the net velocity. So I would like to divide these two equations 1 and 2. So if I divide 1 and 2 equations, then I'll get see, I'm doing this because I would like to eliminate cos phi, and you can observe there is 1 minus cos phi here and there is cos phi minus 1 here. So if you divide those two and also 𝑚𝑢 gets cancelled, then you have only -1 on left hand side. And if you divide 1 and 2, then m gets cancelled, also dt gets cancelled. Then you have dvx upon dv. So now we can simply integrate this with proper limits to get the answer. So when I divide these two and I'll send dv on the other side, you have minus dv is equal to d into vx. So let us integrate this one. So initial value of the velocity is v0, and the final value of the velocity, let's say the final velocity, it reaches horizontally and it will have velocity, some velocity v. So I can write this as v, and that is again along horizontal. And we know that the initial velocity along horizontal is 0. The limits for dvx would be 0 to v. So let me explain this once again. This is minus dv. V is the net velocity. Initial velocity is v0 and final velocity is v. So v0 to v. And along horizontal, initial velocity is 0 because the velocity was only along y-axis, and final velocity becomes v. And now when you integrate minus dv, it would become minus v. With limits, it would be v0 minus v. And on the other side, because there is a minus, so I'm just multiplying minus here, so I got v0 minus v. And integration of dvx is simply vx, and the limits apply v minus 0, then you will get v here. So the v is final velocity which you are supposed to find the velocity of the particle as a function of time, the final velocity. Then you have 2v is equal to v0. Then simply the final velocity v becomes v0 by 2. So v is equal to v0 by 2 is the final horizontal velocity with which the particle moves. And since you see the horizontal velocity here is horizontal force here is F0, which is 𝑚𝑢𝑚g, and in opposite direction there is frictional force which is again is equal to 𝑚𝑢𝑚g. They will cancel. Hence the net force along horizontal is 0, and it would move with constant speed. So constant speed v, which is v0 by 2. So thank you.